All right, so here is the prompt from number 31 in section 9.2 in your textbook. So this is the first significance test we're going to do. Read through the prompt. We see that Jason Reed's report says 80% of U.S. high school students have a computer at home. He believes the proportion is smaller than 0.80 at his large rural high school. Chooses an SRS of 60 students, records whether they have a computer at home. 41 say they do. Does Jason have convincing evidence at the 5% significance level that the proportion is smaller at his rural high school? So we always want to mark our text here, highlight things that are going to be important for us. I see 80% of U.S. high school students. That's going to be probably my assumption, okay? That's going to be what I'm starting off, what I want to check against. He believes the proportion is smaller than 0.80 at his large rural high school. So that kind of confirms what I was thinking. We have this claim of 80% owning a computer. We want to check that claim. Okay? Jason chooses an SRS of 60 students, so there's our simple random sample. We have a random sample size of 60, and 41 tell us they have a computer at home, so that's going to give us our p hat, our sample proportion. Convincing evidence at the 5% significance level, so that's our alpha. So I'm going to write down some of the things that we know. The claim I want to test against is my H naught, and that is that the proportion of students at his high school is the same as the proportion nationwide, 0.80. The alternate, he believes it's actually different. Not just different, but that proportion is smaller. So we'll be looking at less than 0.80. We have to make sure that we define what P is, so we'll go ahead and do that now. We understand that P is going to be the proportion of students at Jason's high school that say they own a computer at home. And that's very important that we specify that it's Jason. So I'll take a second to write that down. Give me just a moment. Okay, so we have our hypothesis statement written out. We've defined our parameter in the population of interest. So let's go ahead and continue writing down things that we know. We know that our sample size is equal to 60, and that was a simple random sample of 60 students. So that's going to help us out knowing that our random condition is now checked. Other conditions that we need to check is we need to check the 10% condition. Well, that's based on the assumption that our population is going to be at least 600. So our population here is the population of students at Jason's large rural high school. Since it's large, I think that this is a fair assumption to make. So we can say that n is less than or equal to 10% of big N. And the last one we need to check is the normal condition. Is the LCC going to be satisfied? Okay, so normal, meaning n times p naught must be greater than or equal to 10, and n times 1 minus p naught must be greater than or equal to 10. Now, p naught, that's the proportion that we found from our null hypothesis, 0.80. Our sample size was 60, so 60 times 0.8, is that greater than 10? Yes, it is. And how about 60 times 1 minus 0.8? 0.2. That's barely greater than 10. That is 12, but that checks out. So all of our conditions are met. Okay? Other things that I want to write down. Notice I don't even have a p hat here. I don't even know what my sample size is. Or I don't even know what my sample proportion is. Well, that comes from the 41 that say they have a computer. P hat is going to be 41 out of my 60. If you punch that into your calculator, 41 divided by 60 is going to be 0.68333 repeating. Okay. A lot of times it's helpful to look at the decimal value instead of just the fraction. So there we have our p hat. And then we also have alpha. The significance level is 0.05. So when we calculate our p-value, that's what we're going to want to compare this against. Okay, so now at this point we've got all of our conditions checked. We can go ahead and calculate that p-value. Let's do that. The p-value comes from the test statistic, or the z-score. which in this case is going to be our p hat, minus what we assume the center of our sampling distribution is, p naught, and then we divide it by the standard deviation of the sampling distribution. Okay? Plugging in all of these things, p hat is 0.683 repeating, minus 0.80 for the p naught. And when we are entering in our sampling deviation, or standard deviation of our sampling distribution, we use p naught. So 0.8 times 0.2 divided by my sample size of 60. Punch that into your calculator, and you will find your z-score. So let's go ahead and do that now. All right, so we're ready to punch everything into our calculator now. Let's go ahead and do that. Can enter in a fraction. My numerator. Oops. Okay, sorry about that. We enter in our numerator, 0.68333 repeating, minus 0.8. Press the down arrow to get into my denominator, and we will enter in our square root. There's another fraction bar here. You don't have to use the fraction bars, but they're available to us. You can also just do division and use your parentheses, okay? 0.8, not divided by, times 0.2 divided by 60. We enter negative 2.259. We'll go and round that to negative 2.26. So that's my z star. Or not my z star, I'm sorry, my z, my test statistic. Negative 2.26. So what that's telling us is that if we were to look at the sampling distribution of all possible samples of 60 students from Jason's school, the mean would be, we assume, 0.80. We got a much smaller sample. 0.683. Oops. Had a z-score of negative 2.26. So that's like more than 2 standard deviations away. What's our probability of getting a sample that's even that or less? Well, that small of a sample, that area under the curve at negative 2.26 for our z-score, that's our p-value. So taking a look at this, z-score on our z-table gives us a p-value of 0.0119. Now, we take that p-value, we compare it to alpha. So our test statistic was negative 2.26. The p-value gave us 0.0119. And we compare 0.0119, saying that that is less than alpha. Since our p-value is less than alpha, we reject the null hypothesis. Okay? So let's write out what that statement looks like. Give me just a moment. Okay. The interpretation here. Since my p-value is less than alpha, I reject the null hypothesis. I have convincing evidence that the true proportion of students at Jason's school that have a computer at home is less than 0.80. What that means is, when we assumed that the population held for 0.80, we got a sample that was only 68% that had a computer at home. That sample size was so incredibly unlikely, only a 1% chance of that happening when we made this assumption, that there must be something wrong with our assumption. That gives me such convincing evidence against the null hypothesis that my alternate must be true. Okay? So please go ahead and take a look at the next example.